Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at a problem on components on an inclined plane. If you look at the question, an object with a mass of 100 kilograms is on an incline. The angle of the incline is 30 degrees at the point just before the object starts to slide. Calculate the Wx and Wy components of the object. What is the maximum static frictional force? What is the normal force acting on the object? Now, if you look at our diagram, we have 100 kilograms on an incline, and the incline is at 30 degrees to the horizontal. So here we have our diagram. We see as a 100 kilogram object, and the object is at 30 degrees to the horizontal. So the first thing we can do is we can put the force of weight. And if you look at this, if you throw force directly down, straight down, because weight acts directly downwards on an object towards the center of the earth, then that will be called W. So the first thing we have to do is to work out W. Now, if you work out W, we see that if you work out W, we can say W is equals to mg, mass times gravity. And our mass of the object is 100 and gravity is 9,8. And 100 times 9,8 will give us 980 newtons. So we know that the force acting downwards towards the center of the earth is 980 newtons. Now that we've got W, we can work out the X component and the Y component of weight. Now, just to remind ourselves, when we talk about the X component of weight, we said in the past that we have to look at the incline. And if you look at the incline, we see that the X direction is parallel to the incline. Along the incline will be the X direction, and perpendicular to the incline will be in this Y direction here, which will be perpendicular to the incline. So if you want to work out Wx, according to this, if you're working out Wx and Wy, we're looking at the X and Y component along the incline. And if we do that, we'll see that our X component will be like this. The component that's parallel to the incline, so that will be Wx. And our Y component will be that one, which will be equal to Wy, which will be perpendicular to the incline. And if we look at this, we came up with a rule that to say that if the angle of the incline is 30 degrees, then the angle here at the top is also 30 degrees, and we won't go into the geometry as to why that angle is 30 degrees, but you can always assume that if the angle of the incline is 30 degrees, then the angle here on the top will always be 30 degrees. And another thing we must know that's very important is that because we have perpendicular and parallel components on the incline, that this angle here will always be 90 degrees. It is always 90 degrees, and that will make our sums easier. And because it is always 90 degrees, we can use our trigonometry ratios to work out Wx and Wy. Now, if you look at Wx, we see that in terms of angle, this angle 30 degrees, then this will be our opposite. This will be our hypotenuse, and that will be our adjacent side. So if you want to work out Wx, it will be Wx over W, and that will be equal to sine of 30 degrees. And we discussed this in a previous video clip, so we won't go into it again. But what you can know, what you can take as a given that if you want to work out the parallel component of weight, Wx is always equals to W sine theta. So if you want to work out Wx, we can say it's equal to W sine theta. Then in our diagram, we can say that if you want to work out Wx is equals to W sine theta, W is equals to 980, and sine theta will be sine of 30 degrees. And if you take our calculator and we say 980 times sine 30 degrees, we get 490 newtons. 980 times sine of 30 degrees is 490 newtons. So that will be 490 newtons. So that will be the x component of weight. So we can say Wx is equals to 490 newtons. And just let's take out this to remove the confusion. So that will be our x component of weight. And if you want to work out our y component of weight, we see that in terms of 30 degrees, this will be adjacent. It will be adjacent over hypotenuse. And this is 30 degrees, this is the adjacent and hypotenuse, and there will be cos of 30 degrees. So what we could do is we know the rule that if you want to work out our perpendicular component of weight, Wy will always be equals to W cos of 30 degrees. So if you work that out, we can say W is equals to 980 times cos of 30 degrees. And if we do this, we say 980 times cos of 30 degrees, we get 848,70. That will be equals to 848,70 newtons. So we can say our Wy is equals to 848,70 newtons. So there we have our Wx and our Wy. Now going further, just to understand it further, that will be our x component and our y component worked out. Number 2 says what is the maximum static frictional force, and number 3 says what is the normal force on an object. Now if you look at this diagram, what we said in the past is that we can take our weight and we can resolve it into components of vectors, and we see that our Wx is acting parallel parallel to the slope, and our Wy, we just take it out, we just take out all the unnecessary components at this point in time to make our life a little bit easier. We see that will be our Wx acting down, and our Wy will be acting in that direction. So we just focus on these aspects that we have here. We got our Wx and our Wy. Now we also said that if you look at the object, because the object is acting on an incline, our normal force will act in that direction, and that will be F normal. We also have another force that is our frictional force acting opposite to the direction of the motion. So if we look carefully here, we can put our frictional force acting in this direction, and that will be our frictional force, and let's just label it as Fs, frictional force, and that will be S, and in this case it will be the maximum frictional force because it is the friction just before our object slides down the slope. So that is important to realize that this will be our frictional force just before the object slides down the slope. So it's friction, but it acts, it's our frictional force, and it acts opposite to the direction of the motion. Now looking at this diagram, very importantly, because the object is standing still, we're looking at the object just before it slides down the slope, we can very importantly deduce the following. We can say that Wx plus Fs, and in this case it will be Fs max, must be equal to 0 because the forces are at equilibrium. Now because they are vectors and we have to take a direction as positive, and we can say that maybe we're taking downwards as positive, that this direction is the positive direction and this is the negative direction, we can say Wx minus the frictional force, and in this case it will be the maximum frictional force, will be equal to 0. So therefore if we take it on the other side, we can say Wx in this case will be equals to Fs max. And what is Wx? We worked it out. W sine theta, which is 490 newtons. So that we can say therefore our static frictional force, the maximum static frictional force in this case will be 490 newtons. And then the last question says calculate the normal force on the object, and we can see here that Wy and the normal force are the same. So similarly, we can say Wy is equals to Fn. And using the same rationale, according to this diagram here, where we can take a direction as positive, etc. And therefore, our normal force in this case will be equals to 848,70 newtons. So this will be a typical way of how to do the sum relating to working out the components of weight and realizing that the parallel component of weight will be equal to static friction and the object is standing still, and the perpendicular component of weight will be equal to the normal force but in the opposite direction. So we will stop there today.